Hello everybody. Hope you guys are doing well. Just let me check if the stream is up and running, and then we will continue. Okay, it has. Uh, your process. Yeah, sometimes glitches can happen, right? So, uh, okay, let's go. Uh, yeah, so let's. Uh, 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 911. Okay, yeah. So the stream is up and running. Let's see if the volume and everything is on. Yeah. Okay, so today we would start about what this World Wide Web is, or what WWW is, and why it came into existence, right? Remember, our goal is not to memorize anything. We will try to understand as much as possible, and I will make sure that we are understanding every process when we study. So now, the first thing, let's study a little bit recap of what, how, and when internet was discovered, right? So ARPANET, basically this was a military wing. This developed the first operational packet switching network, because and it is the backbone to the internet. So this is basically the precursor, or the forefather, or of what the today's modern internet relies on. Now, it was developed in late 1960s by the US Department of Defense. So basically, this all was happening at the time of after World War Three, right? During the Cold War is when we started working on our planet. Now the goal was basically is to create. So first of all, why did the ARPANET development happen in the first place itself? Now remember ARPANET. So remember at that time a lot of research was being done, right? So, and there was this race to become a nuclear power. So what people were thinking is, like what the scientist was or what the military was thinking is, to have a communication network that could even survive some partial outages by rerouting data through an alternative path. So this will basically first lead to the process of a decentralized communication, right? Previously everything was centralized, right? You have so before ARPANET you had phone communication, right? You go to the exchange, the exchange takes you. So if the exchange goes down, the communication is lost, right? You cannot reroute your packets. So but then what these guys they do is try to establish an a communication which, even with the exchange goes down, still could survive and could help in communicating, right? Now the reason for this is because at that time heavy research was being done, right? Again, this is just in 1945 is when the world war ended, right? So this is during the Cold War era, where everyone wanted to, when US was in, not everyone, US was in a race to become a major superpower, right? Thereby undermining the Soviets. So that is when a lot of research was happening. So what these guys thought is, instead of sharing the files from one place to another or carrying it locally, what if we have a central repository wherein people could just come and get the information they needed, um, and then even this could survive partial outages, right? And then the information sharing will become much more easier instead of having it sent to a file to file, like instead of sending the files from one place to another. So now how it was developed, like what's the timeline of ARPANET. Now in 1960 was the need, the people felt that we should have something that should be able to do this, and then this is when the research actually started. Now in 1966 one of the ARPA envisioned a computer, right, a computer network where computers would communicate with each other. Now in 1966 is when Bob Taylor proposed the idea of a network to convert the ARPA funded research computers. In 1967 is when a plan was published, and in 1969 is when it goes live. So on 2nd October 29 on October 29, 1969, the first ARPANET was established by UCLA. Now basically these are what do you say, these are basically but what do we mean by nodes is, suppose if you want to access some research, right, suppose you want to access this UCLA is not a company, it's an University of California, right? It's a university there. Even Stanford, these are all universities, right? So basically these universities were conducting the research, and so UCLA is a very prominent university. Even USC is a very prominent, and so is University of Utah. So what they did is they kind of hosted all these or they kind of made these universities as a node, right? So suppose if I want to access a particular file or which is being, or a research which is conducting at UCLA, you just go to that node, request for the file, and then get the data. Now the first message that was sent was hello, was an attempt to log in, right? Now expansion. Now so in 1969 we already have ARPANET. Now then we expanded it to 15 more nodes. Now, what do we mean by nodes? Nodes is basically these a single nodes is like a point in a system where you can request for some information, right? So this is how it is to work. Now in 1971 the first email was sent by introducing the @ symbol. In 1973 the ARPANET program went international, and you could have University College of London and now in Seismics Array. Again these are two universities, right? Now in 1974 is when Wind, Surf and Bob Kahn published the TCP, or the most famous protocol that we use today, basically Transmission Control Protocol, which evolved later into TCP/IP and the standard protocol for internet communication. Now in 1983 is when TCP/IP was adopted as a standard communication protocol. Then you have 1984 where DNS was introduced, replacing numeric IP addresses, and then in 1990 is when ARPANET was decommissioned, and then other networks like NSF/NET came into existence. Now there is few more things, right? So we were talking these, like they had something called as nodes, right? So let us understand what these nodes actually mean when we say right now. So basically a node is basically like a connection point, I said, within the network that could receive, create, store or send data, right? So remember the research is being carried out at these universities, right? So the major universities where more amount of research was carrying out, they were made the nodes, right? So suppose if you wanted a research paper or some specific information about some specific research bit conducted, you would contact that university node, and then it would give you the data, right? So now each node represented so a node is basically a computer, right, that is connected to the network, often located at research institutions or universities or military sites. Now these nodes were the building blocks of ARPANET, right? So basically earlier we said that communication was node to node, right? You could communicate from one node to the another. Now, a node is basically a host computer, right? Or a mini computer equipped with an interface, message processor, or an IMP. Now, the IMP is a device, basically an early based router that handles the task of receiving, routing, and transmitting packets, right? So, for example, if you wanted to go to say UCLA, you would go to some your node, and then it would send you the some address, and then it would go here, and then it had a unique identifier, right? Basically the earlier form of an IP address, in order to ensure that the data was being sent to the correct destination. So remember in 19 so before the decommissioning of ARPANET, we replaced this network, the node network, with TCP/IP suite, right? So remember, TCP/IP has already been introduced in 1974. So in 1974, we already started establishing that with TCP with TCP/IP generally comes, right? Because these two protocols are interdependent, right? So basically, you have an IP address of the source and the destination that you want to send the information to. I remember the client server model was developed during the ARPA network, right? During the so basically, what we have done, this decentralized communication. By decentralized, what we mean is you have a client that sends that establishes a communication with the a server, and the server sends in the data. So basically, so during this ARPA development as well, or during this ARPA or the initial stage only, we had established the client server model. So till now we said that once the ARPANET came into existence, first of all the client server model was established. Now we had a centralized source, and also TCP/IP suite also has come into existence, right? Now let's see, what do you mean by then why was www, or why was World Wide Web being introduced, right? Now later on, this ARPANET, before decommissioning it only to specific universities and institutions that could do research, later on ARPANET was made global, right? So that anyone who had a computer could be would be, so before going international. Yeah, so this is the moment they made it international. Now you could have ARPANET being able to communicate with different computers at different locations in the world, right? Previously, only at the specific nodes you could have or establish the communication. Now, why there was WW introduced in and what was the advantages? Now in the late 1990s, where we said so in 1990, 1974 we got the TCP/IP suite, right? Or in 1974 we got the TCP/IP. In 1983, TCP/IP was made a standard protocol, marking the birth of internet. So this is how the modern internet works, right? So this is when you are into modern internet. Now in 1984 is when you have the domain name system being introduced, basically replacing numeric IP addresses with human readable domain name. Now in 1990, before decommissioning it, you already have the TCP/IP suite being taken into existence. Already DNS was introduced. Now remember, DNS is so for example, if you have a website, right? So if you have a website called as example.com, so this so this is nothing but my domain name server, right? I mean, what this is nothing but my domain name, which is basically going to be mapped to an IP address. Previously to IP address being previously to introducing DNS, we were directly making use of numeric IP, right? Because the usage of internet was not that much, or usage of ARPANET was not that much. And then once there was a gradual increase, then DNS or domain name system was introduced. So you can say it was basically introduced to replace the numeric IP address with human readable domain. So because we can read this, right, but the computer cannot understand this, it needs a number. So that job of converting a number into an email is sorry, a number into what do you say, a number into, or a name into a number, is nothing but called as um, uh, domain name server, right? And then why did we have www being introduced? Like why was this whole concept of world wide web being introduced? Now CERN is basically a research organization. So this www was introduced by Tim Berners-Lee. Now later on he was knighted by the queen, so he's referred to as Tim Berners-Lee because of his significant constitution, because of his significant contribution in today's modern world, which relies on this www. Now, what Tim Berners-Lee worked on, not now remember, as and when the need arises, remember there was this issue, right? One issue was you could only request, you could have the information being stored at a central repository, right? And you could so remember at that time research was carrying out, right? So research papers are basically documents, right? So then what Tim Berners-Lee thought is, why not use so instead of having to for example, if this is one node and this is another node, and the research, so two related papers are published at two different universities, right, or two different nodes. So what I had to do is, I had to first go to this and then again go to so I had to first make a connection to this node. Then once I have the information, then I need to make a connection to this node. So this is a huge problem, right? It's basically leading to a issue, right, that you had to go to each specific node to get the data. Now what Tim Berners-Lee did was he said, he introduced the concept of something called as hypertext. So hypertext is basically, you could connect this information, like these two could be connected to each other with just with the help of an hypertext, right? So this is when hypertext was introduced, or when Tim Berners-Lee laid the foundation of this, of the of hypertext, right? So now what you have done is, instead of me going to this and to this node and this node, what I can do is, I can just go to this node and then using an hypertext I could land up here. So what basically it achieved was is non-linear navigation, right? Okay, because you can previously traditional document. So remember, hypertext is basically allowing us to do this a non-linear sort of movement, right? Now now previous to hypertext, so remember these are all documents, right? Because at that time research was being conducted, so documents were being published, right? So remember, traditional, if you see a traditional document, it is generally read from top to bottom until finished, right? You do not have an option to skip something or do something else, right? So this is basically useful for scientific research, right? While cross-referencing and connecting related ideas and are essential, right? So this is nothing but what do you mean by so this is what enabled us to bring in or the word hypertext came into existence, right? Now so basically what it did was, first of all, it made the system very intuitive, right? So you can, with the help of one click, you can navigate between documents without knowing complex commands or file path, right? So you need to know the exact location where that, on that node, on which computer, in which folder is our file stored. So you need to access that particular file as well. So basically you need to write a command in your CLI, right? Now that once hypertext came into existence, you could just use a link, and then all the information in that link will directly let you access without the need to mention these difficult things. Now, Tim Berners-Lee was inspired by such hypertext because he knew what an hypertext system could do, right? So that is when he started working, and he introduced this concept of worldwide web, or something called as a hypertext. Basically, a world wide web, or something called as HTTP, right? Now, this is when the foundations of hypertext as was laid down. Now, what is HTTP? Now, when if you start using hypertext to connect or to navigate between two pages, now you need some mechanism or some protocol, right? That could do this, right? So HTTP basically stands for Hypertext Transfer Protocol. So basically, by transfer is you mean is you are going to get back some data in a text based like format, which is not present at which is basically made up of HTML documents, right? So it is this for the first time HTML or hypertext markup language was being introduced. Now, okay, now let's see a little bit more about this hypertext thing, right? Okay, now with the need, okay, previous to www, we used to use. There are other forms of web as well, right? One is you can do a file transfer. You can use Gopher. You can use um um Telnet. Remember, but using all this would need us to um um know some commands, right? Now, this is when we introduced this concept of, instead of having it instead of using other, let's use www, right? And now, okay, with when we came to www, what other things that were introduced were, first is basically HTTP, right? And next is basically we introduce something called as a uniform resource locator, or nothing but called as URL. So basically, remember we said we need to access that specific file or folder, right? So this is nothing but, what do we mean by the uniform resource locator, right? It's much like a path to a file, right? It will be having certain directory. It is much like how you mention a file path in directories. Now, using this, okay, so but then the doubt arises is, we said that in example.com, the example.com refers for the domain, right? So let me type it out. For example, this is our website, right? I mean, so in this we said that the latter part is nothing but indicating the domain, right? I mean, this is for the domain. So then why does the default page or the root page open? Now that is how it is designed, right? If it flashes, if it finds a slash at the end, it's made to go to the, or so in the file path you will have the root path, right? So when you don't have anything, by default you navigate to the root location, and whatever is present at the root, that will be given out. So this part, or this example.com, is just to give the IP address of the server. Now it's a server because we need the service, right? Now this slash is nothing but, if you don't mention anything, by default it takes a slash. Now this slash assumes that we are navigating to the root path of that file. Now generally there is a the file, you have many directories, right? So for is a tree like structure, right? You will have root, then you will have again folder. In that you will have file. So whenever you hit to slash, you hit to this URL. Sorry, to so you are going to this specific address to locate the resource. And generally this is where you have your home page being present, right? So whenever you hit this slash URL, you will get this home page being given out. Now okay, so now with www, there is one we said that hypertext was introduced, right? So now then came in something called as so once we had hypertext, then we came something called as a protocol, right? How will the transfer work? So then is when we introduced the concept of HTTP, right? Now remember, there are multiple versions of this HTTP enabled, right? So previously this HTTP in 1.0 you did not have pipelining, right? So basically you cannot send in multiple requests, right? You had to wait for each request to happen, and then that is the improvement that was made in HTTPS, right? So you did something called as an sorry, you then came not HTTPS, in the HTTP 2.0 version is what we mostly use today. And so that is when this HTTP 2.0 came into picture, and this had pipelining, right? You could send in multiple requests and wait for. So this concept comes from processor, right? So by pipelining, what you mean? So remember, a processor will do three things, right? Fetch, execute, and decode, right? So while what we do is, while we are executing or while we are decoding, we kind of fetch the next instructions and keep it in available in the program counter. So this is basically enabled using pipelining. Similarly, what we are doing is, instead of having one single multiple and waiting it for to be completed, we send in multiple requests. Now this is what is nothing but called as uh, HTTP or HTTP 2.0. Now the now remember, HTTP is not a safe protocol, right? So then the safe version, you had HTTPS being introduced, right? So generally all our website are now having this HTTPS a website. So now if you break down, so let's consider an example and try to understand the URL, right? Or try to understand how, what, and how we are trying, how we are like what are the different parts that it will contain. So this is a URL. So remember, so we said that this is nothing but used to give my domain name, right? So this is going to give me the IP address of the server, right? So this is going to be taken out by the this is going to the DNS to give me the IP of the server from the name. Now this is what is coming in. Now this basically is going to so once we have reached to the server, this is what is mentioning. So this is the server, that specific file that we need to access. So this is what is being mentioned by that. Now and www, now this indicates that we are using World Wide Web, right? So whenever we are dealing with World Wide Web, remember what we are expecting is a hypertext being set, being, or a document being returned to us. Now the way that document transfer will take place is controlled by this protocol, which is called as HTTP, or which basically stands for Hypertext Transfer Protocol. Now this is basically a version of HTTP that is indicating safety or a secure version of HTTP. Okay. Um. Um. So this is how our uh, basically URL is basically consist, right? Now this S is for safety. We'll see that later on how that do later on uh, that what do you say, like how that safety feature is being included. Right now we are not um, dealing with that, but we'll see that later on. Yeah, so um yeah, so yeah, that is all for um this lecture. I hope you guys how this www and http uh are interlinked with each other, and uh uh yeah, so now before having or before doing or requesting hypertext, there are other ways as well. You could have file transfer, or you could have a Tor dark web, basically using an onion or a Tor browser. Like an on, it's called as onion because like an onion you have deep layers, right? So when you peel an onion, it's not a single layer, right? The more you keep on going inside, the more it is, right? So just like that is the security, right? I mean, you have added layers of security for Tor or dark web browsing. uh so yeah, I guess that's all for yeah, so I guess this whole conceptualization of ww and hypertext is uh, basically was developed by Tim Berners-Lee, which is now what we call as the foundation for internet, right? So this is what we use right now. So basically what it does is it says that everything is basically a document, right? Your all your websites are just nothing but plain documents. So we would be receiving and sharing information in a document like format. Now this S basically comes for added security. There is a problem with normal HTTP, right? We'll see when we fill out forms. I mean, there is a video on YouTube. I don't know if you haven't seen it, wherein a professor displays how a person can do a man in the middle attack and take out the data. So we'll see that later on when we come to encryption and cryptography. But this is the major thing that I wanted you to understand, right? How is what do you say, how is a URL being developed, or what are the different parts of URL. So I guess that is all for this lecture. I'll see you guys in the um, next one. Till that time, take care. Bye bye.